Hi, my name is Andrew Melock, and my presentation today is on the development and implementation of the Global Navigation Satellite System, or GNSS. The forefather to GPS was the Navy Transit Program. After the USSR launched Sputnik on October 4, 1957, scientists at Johns Hopkins University Advanced Physics Laboratory were able to predict when Sputnik would be in view using the Doppler effect. The Doppler effect is an increase or decrease in the frequency of sound, light, or other waves as the source and observer move toward or away from each other. This gave scientists the idea of what if it worked the other way around? Instead of tracking objects in space, it could be used to track objects on the ground. This concept led to the Navy Transit Program. The Navy Transit Program was the world's first GPS system and entered service in 1964. The NTP provided accurate navigation for naval surface ships and submarines. In 1967, the NTP became available to all ships regardless of nationality. The NTP consisted of 16 satellites orbiting 600 miles above the Earth. The NTP lasted until 1998 when the operational life of the satellites ran out. In the early 1970s, the United States government wanted a more robust and accurate system than the Naval Transit Program. In November of 1972, Air Force Colonel Bradford Parkinson was assigned to oversee the development of a new global positioning system. Parkinson led a team in developing a concept that synthesized the best aspects of the Naval Transit Program, Timation, and Project 621B. With the development of atomic clocks at the Naval Research Laboratory's Naval Center for Space Technology, led to advances in satellite-based navigation system known as Timation or time navigation. The first two Timation satellites launched in 1967 and 1968. They were equipped with crystal oscillator clocks. A third satellite launched in 1974 became the first equipped with an atomic clock, which greatly improved accuracy and provided three-dimensional location coverage. Project 621B was a project to increase accuracy, and they found that if at least 4 satellites were in view of the receiver would not need a highly accurate clock. This cut down significantly on production costs. This revised system proposal received Defense Department approval in December of 1973 for a system of 24 satellites, which used atomic clocks at medium Earth orbits. This was the foundation of the modern GPS system we have today. In early 1974, the plan was approved and then began development of Navstar satellite, ground stations, and receivers. In February of 1978, the first Navstar satellite was launched, with 3 more Navstar satellites being launched by the end of the year. In 1983, President Ronald Reagan authorized the use of Navstar, or GPS as it became known, by civilian commercial airlines in an attempt to improve navigation and safety for air travel. This was the first step in allowing the use of GPS by civilians. GPS technology continued to improve through the 1980s and 90s. The production and development phase began in 1985, and the first operational GPS Block 2 satellite was launched on a Delta II rocket in 1989. The Block 2 satellites were the next generation of GPS satellite, improving accuracy and satellite longevity. Concern also grew within the government that the enemies of the United States could utilize the GPS system and its information against the U.S. In response, the Department of Defense decided to adjust the system to be less accurate in non-military applications in order to deter any usage by enemies. This was known as selective availability. The new global positioning system was mainly used by the civilian airlines to improve air safety. Although GPS receivers were available for anyone to buy, they were very expensive. In 1989, there were commercially available handheld GPS units that hit the market. including the Magellan Corporation's Magellan Nav 1000. The Nav 1000 weighed only 1.5 pounds, offered just a few hours of battery life, and cost $3,000. In 1999, the first mobile phone with GPS was released. The mobile phone was made by Benephone and called the Benephone Escape! In 2000, the United States government ended the Selective Availability Program that decreased the accuracy available by civilian GPS users. As a result of this decision, GPS signals instantly became 10 times more accurate for civilians overnight. The price of GPS receivers and processing chips also dropped drastically from about $3,000 to $1.50. This was due to the development of better manufacturing processes. The increase in accuracy, coupled with the decrease in cost, led to exponential growth in the GPS usage for in-car navigation, location-based services, personal technology, and uses in shipping, sailing, and other industries. By 2001, it was recognized that the system needed to be modernized to meet rapidly expanding military and civilian applications. A new strategy to add new signals to the satellites not yet launched was developed. In order to meet the full modernization requirements, it would take a new program that was designated GPS-3. By 2005, the Block 2 satellites had 5 different configurations with different capabilities. Original 2s, 2As, and 2Rs were already in orbit. But the 8 modernized 2RMs began to be launched in late 2005, with 12 modernized 2Fs in full development. The first modernized 2F was launched in 2010, with the remainder being launched by 2017. The first GPS-3 satellite was launched in 2018 using a SpaceX Falcon 9 rocket, followed by the second launch of the GPS satellite in 2019. The rest of the GPS-3 satellites are scheduled to be in orbit by 2023. The impact of space-based navigation technology on our world continues, with some reports estimating that since the 1980s, GPS satellites have helped generate nearly $1.4 trillion in economic benefits. A 2019 study estimated that between 2007 and 2017, GPS-enabled location services such as Google Maps helped American consumers save 52 billion gallons of fuel and drive over 1 trillion fewer vehicle miles. We also use it for the scientific study of earthquakes, volcanoes, and the movement of tectonic plates. Space-based navigation is used to aid construction and optimize farming, including the application of water and pesticides. I hope you enjoyed my presentation and have a wonderful day.